So here it is. It is made of over 230 integrated circuits distributed across these 9 separate 2-layer boards. Again, as this is a discrete build, there are no FPGAs nor any microcontrollers. And here is the front panel, where we can find things like the USB-C connector for power, the on and off switch, LED indicator, reset button, the programming connector, VGA output, 2 input and 2 output ports. They are 8-bit each. And I almost forgot, there is a small hidden feature, and is this small little 7-segment display, and the intention here was to use it as some sort of an indicator, similar to how modern motherboards have. And I think now it is time to turn this on. So I will plug my 5V charger in and turn it on. And that's it, the CPU is running, but we cannot see much. That is why I've created these modules. The first one has just 8 buttons. I can connect it to a port B of my CPU, and now we can send some inputs. To see some outputs from the CPU, I've also created this module with 8 LEDs, and I can plug it into a port C. Now you can see a very simple animation that is playing, and I can change it by pressing different buttons. This is just for demonstrative purposes, but if you want to do something more productive, let's say, I have a PS2 adapter that allows you to connect a PS2 keyboard to my CPU. I will unplug all of these so we will have some more space, and I will plug it into a port A. And the last thing remaining is just to connect an external monitor. So I'll do that here. And the monitor should now turn on, and it does. And here we have a Pine Shell, my very simple shell-like program that accepts some commands, like hi, for example. It will respond by saying hello. I can type hello back, and it will say hi. Pretty neat, right? I can clear the screen using the clear command, and if I want to see some system information, I will type system information. Here are they, and I can get back to my shell program by pressing the escape button. And for those of you who remember the old pick and poke command, well, my CPU supports it as well. I can type poke and some address and some value, let's say AB. I've chosen this address because this is the address that is mapped in memory space to the video RAM. So if I press enter, it will write a byte of data, and in our case this is AB in binary here to the start of our video RAM. Cool, right? I can type peak if I want to read some values, and I will use the same address, and we should get the same value back. So I will press enter, and we've got AB. It is working. Cool. We can clear the screen and we may continue. And if we get ports or something else, well, I've got you covered. I've programmed a very simple snake game.